Hare Krishna. Hope you're doing well. Let's get started with this question on hypothesis testing. You have to find the power of the most powerful test of the given size. Naturally, there's the use of Neyman Pearson lemma and the concepts of size and power. So let's get started. Now, it's a very protocol based sum. You just have to follow the set of protocols associated with Neyman Pearson lemma, which states that your test is going to be given like this. This is the test function. 1 means reject h naught, 0 means accept h naught. And the test, because it's a continuous distribution, it's going to be of this form where lambda is the ratio of PDF under alternate hypothesis to PDF under null hypothesis. That's where you can maybe go wrong, that you end up taking the opposite, which is the reciprocal of this f naught x divided by f1x. So that's something to be mindful of. Generally, it's confusing because in Neyman Pearson lemma, it's like this, but in likelihood ratio test, LRT tests, the structure is something like supremum of under numerator is supremum under the joint PDF under null, and the denominator is the supremum under the entire unrestricted domain. So that is why there can be confusion, that here this thing is on top and this one on the bottom, but in likelihood ratio test this similar structure is on the top. So just being mindful is good. Now we are going to get a test of this structure, right? And the intuition is, when we have this lambda x, we try to find a easier representation of this, something like, if we can get lambda x greater than k if and only if it's a function of x, then that simplifies our representation of the test function and makes the computation of size and power also easy. In this case, it's pretty easy. 2x is a monotonically increasing function in x. So if 2x is being greater than some quantity, it's only possible if and only if x is also greater than some kind of quantity. Uh, and then we just get this threshold, that what is this threshold which satisfies the size alpha. We get it by this thing, that we are rejection region is of this form, and this has to be equal to the size, so we back calculate this. So c is equal to 1 minus alpha, and then the same rejection region, that x is greater than 1 minus alpha, we use to compute the power, which is rejection of the null hypothesis when the alternate is true. And pretty simple integration will give you the answer. That's it. Again, protocol. You find this ratio, you find that simple function which is monotonically increasing with lambda x, and then based on the given size, you find that threshold of the rejection region, and then you find the power. That's it. Take care. Hare Krishna.